All right, let's talk about one of the biggest game changers in tech right now, large language models. You probably know them as LLMs. We're going to peel back the layers and see what really makes these things tick.
I mean, you've seen them everywhere, right? They can whip up a poem, spit out working code, answer ridiculously complex questions. It's kind of wild. But what's actually happening behind the curtain? What is an LLM, really? Well, that's the big question today. So, to really wrap our heads around this, we're going to start big, like really big. We'll look at the whole universe of this technology, and then we're going to zoom all the way in on the star of the show, the LLM itself. First, let's talk about the big this all lives in, generative AI. Think of this as the giant umbrella that covers any kind of AI that can create brand new stuff, realistic content. We're talking about AI that can generate an image from scratch, compose music, and of course, write text. And that's exactly where LLMs fit in. They're a really, really powerful type of generative AI. At their core, they're these massive neural networks that have been fed an insane amount of data from the internet. And their main job, it sounds almost too simple, is just to predict the next word in a sentence. But by doing that over and over again at lightning speed, they create text that feels incredibly human. And you've definitely heard of the big players, right? GPT, Llama, Palm. And what's really fascinating is that as these models get bigger, they just get smarter. It's not just about generating text anymore. Now they can classify information, summarize huge documents for you, and are even starting to show signs of actual reasoning. Okay, so here's one of the most mind-bending things about LLMs. They have this incredible ability to learn new skills on the fly, without having to go back to school and be completely retrained. And that's the real secret to how they're so fast and versatile. It's all thanks to something called in-context learning. So check this out. If you just give an LLM an instruction, that's called zero shot. The results can be hit or miss. But if you give it just one good example, that's one shot. The accuracy just skyrockets. And if you give it a few examples, or few shot, well, the results get even better. It's literally learning from the examples you give it right there in the prompt. No retraining needed. So what's the engine that makes all of this incredible possible? What's going on in the power plant of an LLM? Let's take a look under the hood. Well, that engine has a name. At the very heart of every modern LLM is something called the transformer architecture. This was a total game changer because it allows the model to look at a whole sentence at once instead of just word by word. And that's huge for understanding context. It basically works in a few steps. First, tokenization chops up your text into little pieces, words or even parts of words. Then, encoders turn those pieces into numbers, like coordinates on a map. The decoders do the opposite. They take numbers and turn them back into new words to form the response. And the real magic, the secret sauce, is self-attention. That's the mechanism that lets the model figure out how important each word is to all the other words in the sentence. It's how it gets the context. Now, this is super important to remember. Not all LLMs are the same. It's not a one-size-fits-all kind of thing. You can think of them like different tools in a toolbox, each designed for a very specific job. You can really break them down into three flavors. First, you've got encoder-only models, like BERT. These guys are amazing at understanding text that already exists. Think classification or sentiment analysis. Then you have decoder-only models, like GPT. Their whole purpose in life is to generate new text. And finally, you have encoder-decoder models. These are perfect for tasks that transform something, like translating. Okay, so we know a bit about how they work. Now for the fun part. How do we control them? Because when you're using an LLM, you're not just a passenger along for the ride. You're actually in the director's chair, and you've got a bunch of controls at your fingertips. So here are some of the main dials you can turn. Max tokens is easy. That just sets how long the response can be. Then you get into the strategy. Greedy decoding is the safest bet. It always picks the most predictable next word. Can be a little boring though. Random sampling throws a little bit of chance in there to make things more interesting. And then you have things like top K and top P, which help you find that sweet spot between being creative and, actually making sense. But my absolute favorite setting is called temperature. Seriously, just think of it as a creativity dial. If you turn the temperature down low, you're going to get very focused, safe, and coherent answers. The AI sticks to the script. But if you crank that temperature up, whoa, you get way more creative, diverse, and sometimes really surprising results. It's all about what you need for the job. So, why does any of this technical stuff even matter?
It's simple, really. Understanding what an LLM is, how it's built, and how you can actually tune it, that helps us all use this incredible power more effectively. And, just as important, it helps us understand what it can't do, to see its limits. Look, we are just at the very beginning of this whole thing. We're starting to figure out the how it all works. But the real question, the one that we all need to start thinking about, is how are we as a society going to use this incredible new power?